Hi everyone. Okay, so today we're going to do a little bit of differentiation. This would be Calculus 1, the product rule, one of the first big time rules after you learn the basic differentiation. So the product rule is used when you have a product, obviously, of two expressions. So I'm going to call f of x a function, which is equal to u times v, where u is an expression of x and v is an expression of x. And I'll show you what I mean in a second. The basic rule looks like this. If I want to take the first derivative, which is represented by this notation, f prime of x, what we do is we take the first expression, multiply that by the derivative of the second, plus the second expression multiplied by the derivative of the first. So this is just a little basic way of representing it in general. So this is kind of like a formula. But what makes it easier to do this is to say this out loud. And I usually do this with my students in my class. When we find the first derivative, I make you guys go, well, follow me. We're going to take the first, multiply by the derivative of the second, plus the second times the derivative of the first. So you guys repeat with me now. It's the first times the derivative of the second, plus the second times the derivative of the first. Usually when we repeat it 3 times, we remember the first times the derivative of the second plus the second times the derivative of the first. So let's use what we're saying, okay? For example, you guys see that? Yeah. Let's let a function be the product of, let's just make it easy, 2x times 3x squared, okay? And in order to do the product rule, you guys should know your basic power rule, which I hope you know by now. And if you don't, go check that video out. And I want f prime of x. And we're going to find the first derivative by using the product rule. Now this obviously, this type of function doesn't necessarily need the product rule to derive, but we're going to use the product rule for practice here because you're going to see that there are other functions later on that you guys will not be able to get away from the product rule with. So this is like my u and this is like my v from my formula. So u is my first expression, v is my second. So we're going to do this. To find f prime of x, we take the first, 2x, copy it down, times the derivative of the second, and the derivative of v, which is 3x squared, is 6x. First times the derivative of the second plus the second, meaning copy it down, times the derivative of the first, the derivative of u, which is 2x, the derivative of that is just basically 2. So I have u times v prime plus v times u prime. The first times the derivative of the second plus the second times the derivative of the first. And then we simplify. Okay, that's why I have you guys say it out loud 3 times, at least 3 times, because you start to memorize it. And then, of course, I have to simplify, but 2x times 6x, 12x squared, plus 6x squared, which will simplify into 18x squared. And like I told you guys, I don't technically have to use the product rule for this particular function, because if I go ahead and I start at the beginning and I multiply it out, 6x to the third, right? Then taking the first derivative of that is simply 18x squared. I get the same thing. This way it's faster. However, we're practicing the product rule for this case. Okay, we're using a basic example. All right, let's do another one. F of x is equal to, let's let f of x be 5x squared minus 3 times 4x to the third minus 4x plus 1. How about that? Again, this is a particular example in which we don't need to use the product rule, but we're practicing the product rule, so we're going to use it for this case. Later on, when you guys know all your rules and you practice all your rules and you have to basically look at a function and identify which rule would be the quickest way to find the first derivative, then you just use whatever's the quickest method. But we're practicing the product rule now, so we're using it on purpose. So in this case, this would be my u and this would be my v. So again, we say it out loud. F prime of x is equal to the first. Copy it down. times the derivative of the second. And the derivative of this is equal to 12x squared minus 4 plus. So the first times the derivative of the second plus the second, which is 4x to the third minus 4x plus 1, times the derivative of the first, which is just 10x. Again, I'm going to write this down. U, v prime, v, u prime. It's the first times the derivative of the second plus the second times the derivative of the first. And I always double check before I go and simplify because it would suck to simplify the wrong expression. Okay, now to simplify this, we need to multiply these, and combine like terms. So I have a FOIL situation here. I'm going to just go ahead and do this fast. 5x squared times 12x squared is 60x to the fourth. 5x squared times negative 4 is negative 20x squared. Inner, I get negative 36x squared. And last, plus 12 for the first product. Plus, this 10x is going to distribute here. I get 40x to the fourth minus 40x squared plus 10x. And then combine like terms, so I have a 60x to the fourth and a 40x to the fourth, 100x to the fourth. No x to the third terms. I have a negative 20x squared, a negative 36x squared, which is negative 56, and a negative 40x squared, which is a negative 96x squared. The 10x all by itself, and then unfortunately 12 all by himself, and here is my first derivative using the product rule. Okay. Now I want to do a couple more advanced cases. What I'm going to do is I'm going to do that in my second video. So this would be differentiation product rule video 1. Okay, with my nice basic examples. I'm going to do a little bit more complicated cases in the next video, so check it out if you need that. So those will represent product rules with chain rules inside. And if you haven't done the chain rule yet, then you don't want to do that yet. When you get to that, you'll go ahead and watch that video. But for now, this is just a basic product rule. Okay, if you guys need more examples, let me know. Otherwise, have a good one. Till